So guys, get you to have a bit of a pause. I'm going to go over question 5 and 6 from exercise 2C. So when we write a test, okay, this is the conditions that SACE sets for us, is that 60 to 70% of the marks are what we call routine order questions, okay? So they're sort of pretty straightforward. Use the chain rule, apply it. Use the product rule, apply it, okay? Then the other 30 to 40% of marks are what we call higher order complex reasoning, okay? And so they're the harder problems. And both of these questions here are good examples of that. Particularly question 6, okay? If you look at the old tests that are coming up for our first topic, you'll see this kind of question. So not exactly the same, like different numbers, but the same structure appear maybe 3 times, okay? So it's a question that we have asked in the past, and it's important that we do understand it, okay? That being said, it might mean we need a bit of repeated exposure to it before we can start to understand what's going on. With all of these questions, like I wouldn't expect you to be able to just go ahead and solve it. It's, I think it's something you need to be shown, and then you'll be able to reciprocate that process. So let's get into 5 here. All right. We need to find A and B for this function f of x, given this is f dash of x. So if we look at this function, we're familiar with this type of function. We know that that is a quadratic. Okay? That's a quadratic because the leading power is a 2. So if that's the derivative, if the derivative is a quadratic, it has a leading power of 2. That means f of x, the function that we differentiated, has to be a cubic, okay? It has to be a cubic because when you differentiate a cubic, you get a quadratic, okay? We differentiate a cubic, we get a quadratic. Here we've got a quadratic, which means we have to have differentiated a cubic. In here we have a linear factor, 2x take b, which means a has to be 3, all right? A has to be 3, there's no other way around it. And to discover that, that just requires a bit of intuition. You just have to sort of notice that. And A has to be a 3 because if we were to fully expand this, we would see that out the front we would have 8x to the power of 3. All right, and we'll do that in a moment. Okay, so A has to equal 3. So that means f of x really is 2x take b to the power of 3. Now we can differentiate this using the chain rule, okay? Because then we can equate the derivative with this term up here, this equation up here. So we're going to apply the chain rule. Even though we don't know what this is, we just treat it as if it's a number. So let's go in and apply the chain rule. Okay, I've written it up here and we've been recapping it in this exercise, f of x to the power of n. We can see we have 2x take b to the power of 3. So when we differentiate that, we're going to have n f of x to the n take 1, okay? And then that is multiplied by f dash of x, the derivative of the inside here. B is just a number, so that disappears. The derivative of a constant is 0, and 2x, that goes to 2. So that's what we're left with. And now we're going to expand this, we're going to fully expand it and equate it with f dash of x up here. So to expand this, I'm going to move that 2 to the front. Remember, order of multiplication doesn't matter. 3 times 2, that'll be 6 at the front. And then I'm going to perform this perfect square expansion separately and then distribute the 6. So I'm looking at this part here. 2x take b squared. Okay, that's going to be 4x squared. Take 2 lots of 2x times b and then plus b squared. That's just the perfect square rule. Okay, and then we'll expand it. 6 times 4 is 24x squared. Here we have 2 times 2 times b, so that's 4b times 6 is 24bx, and then plus b squared, plus 6b squared. Okay, then we can equate this function with this one. Okay, what do? Here's f of x, here's f dash of x. Alright, and all of these are f dash of x, we've expanded it, and now it's written in the same form that this one is. Okay, and so we can start to equate the terms that correspond. We can see that 6b squared equals 6. So that gives us b squared is 1, and that gives us b is plus or minus 1. Okay, but we have minus 24b is equal to minus 24. Okay? So if we look at this equation, the only value of b that makes this true is positive 1. Alright? So notice how plus or minus 1 will satisfy this part of it, but it won't satisfy this part of it. So we have to restrict our solution. The solution is b equals 1. It can't equal negative 1, because if it equals negative 1, then this part becomes plus 24x, which is not what we have up here. So b has to equal 1. That's our solution. So be careful for that. Don't just process this and say, yes, I've got the answer. The answer needs to satisfy it at every point. So that's where we went through to check. Okay, any questions about that one? Excellent. So then let's move on to 6 here. Okay, this is a beautiful problem. We need to find A and B. We need to find A and B. So what we've got is we've got these two pieces of information. Firstly, we've got when x is 3, y is 1. So we've got a coordinate. Let's use that one first. When x is 3, y is 1. When x is 3, y is 1. And I'm just going to plug both of those pieces of information into the equation. We've got 1 equals A and the square root of 1 plus 3b. Okay, I've substituted 1 where the y is, and I've substituted 3 where the x is. And then we can just multiply both sides by the square root of 1 plus 3b. Okay, and what we'll get is the square root of 1 plus 3b is equal to a. We have an expression for a. All right, just move this up here. We've got a by itself. So you can see because we have two variables, two unknowns, we're going to be developing some form of simultaneous equation. So we've already used this piece of information. All right, so now we need to use the other piece of information and then integrate them somehow. So the next piece of information is that the slope when x is 3 is minus 1 on 8. So we need to plug that into the slope function, which means that we need to find the slope function first. So we need to differentiate this. So if we're going to differentiate it, firstly we should express it in a form that we can. A times 1 plus bx to the half, okay, negative half. Sorry, it's at the bottom, we're bringing it to the top. And now let's apply the chain rule. All right, straight away, one step. dy on dx is going to be a times half a times my fn, f of x, n take 1, and then multiplied by the derivative of the inside. Okay, 1 plus bx goes to b. Alright, so that's quite tricky there, okay, because we're differentiating the function. We don't have any numbers there, other than the power, but the same rule applies. That's staying out front. N, f of x, n take 1, times f dash of x. Okay, now let's simplify that so that it's in a form that we can use. Alright, so I'm looking along here, and I'm seeing we're going to have AB at the top, minus AB at the top, and at the bottom we're going to have 2, we've got 2 at the bottom, and then 1 plus bx to the power of 3 on 2. Okay, so that's in a form that's a bit more usable for us, a bit more manageable. Alright, now what we should remember as well is if we have the square root of x, that's x to the half. If we have x root x, that's x to the 3 on 2. If we have x squared root x, x to the 5 on 2, etc. Okay, look at this. X root x is x to the 3 on 2. So that means we can express this term as a root. And that's going to be helpful for us. So this is actually equal to minus AB on 2 times 1 plus bx times the square root of 1 plus bx. Okay? Remember, to the power of 3 on 2, you can write it as x root x. Alright, now let's use, all we've done there is find the derivative. Okay, we haven't used any of the information that we've got. So now let's use this information. When x is 3, dy on dx is minus 1 on 8. Let's use that now. When x is 3, dy on dx is minus 1 on 8. Okay, now the first thing, when I'm going to equate them, we've got minus 1 on 8 equals AB on 1 plus 3b times the square root of 1 plus 3b. I might just put the b in for now while I'm talking about this. The first thing I'm going to notice is that they're both negative. There's negative on both sides, so we can get rid of that straight away. Okay? The second thing to notice is that we can substitute a in straight away. Remember, we have an expression for a, so let's put that where the a is, which is the square root of 1 plus 3b. And you can see how beautiful this is. We've got the product of the square root of 1 plus 3b at the top and the bottom. That's going to cancel nicely. And now we're left with something that's a lot more manageable. Okay? And in this step as well, okay, what I'm going to do, multiply both sides by 2. That's going to allow me to get rid of that denominator. Okay, so if I multiply 1 and 8 by 2, that's going to give me a quarter. Equals b on 1 plus 3b. Okay, now we can cross multiply there. Let's move that one up there and this one up here. We'll have 1 plus 3b equals 4b. Move that over, we'll have 1b equals 1. B is 1. Alright, so we've found b, and then we can use that to find a. A is the square root of 1 plus 3b. So a is going to be the square root of 1 plus 3 times 1, square root of 4, which is plus 1. Alright. So that's how that's done. It's pretty, there's a fair bit going on. You've got to use all the information, synthesize it together. Are there any questions about it?
Can we get one that high?
Yeah, you can definitely be asked. You can expect something this challenging. Yep, absolutely. 30 to 40% of your marks are going to be higher order complex reasoning. Yep. All right. If people want, I can go through 7 as well.